Okay, I'm going to work out the odd questions for your Chapter 7 study guide. Question number 1 asks whether the angles are adjacent or vertical and to find the value of x. So here's the two angles I'm looking at, this one here and this one here. We talked about angles that you just jump over the vertex, so I know that these two angles are vertical. And the important thing to remember about vertical angles is that vertical angles are congruent, which means they are equal to each other. So I can set these two measurements equal to each other and then just solve for x. So I'm going to add 4 to both sides. 107 plus 4 is 111, and that's equal to 3x. And now I'm going to divide both sides by 3. So x is equal to 111 divided by 3. That is 37. So the angles are vertical, and the value of x is 37. All right, question number 3 asks you to tell whether the angles are complementary, supplementary, or neither. And the way I can prove this is by adding up the measurements given, because complementary angles will add up to 180. Oops, I said that wrong. They'll add up to 90 degrees. Supplementary angles will add up to 180 degrees, and if they don't add up to either one of those, it'll just be neither. So here I have 43 plus 57. If I add that up, that's equal to 100, and that's not 90 or 180, so your answer is neither. Okay, question number 5 asks you to find the value of x, then classify. So it's asking for two things. So the first thing I'm going to do is find the value of x. I know that this is a triangle, and the interior angles, the inside angles of a triangle equal 180 degrees. So I can set up an equation, 39 plus 125 plus x, and set that all up equal to 180. Now I can simplify. So I have 39 plus 125. And that's equal to 164 plus x is equal to 180. Solve for x by subtracting 164 from both sides. So x is equal to 16. So that's my value of x, but now I need to go back and classify the triangle. Well, I know that this is 39 degrees, which is acute. X is 16 degrees, so this is acute. So there's my two acute angles that every triangle has. So I look at this third angle, which is greater than 90, so it is obtuse. So that's talking about my angle measurements. And because all of these are different, that means my side lengths are different too. So this is an obtuse scalene triangle. There's my first, middle, and last name. All right, the next thing I'm going to do is drawing a triangle with these given measurements. So let me grab a protractor. All right, to start with my triangle, the first thing I'm going to do is just sketch a line down here. It doesn't matter how long it is. Okay, now I'm going to create a vertex. And now I'm going to start with my 80-degree angle because drawing larger angles is sometimes simpler. So now I'm going to line up my vertex and my line. And I'm going to go up to 80, so there's 10, 20, 30, 40, 50, 60, 70, 80. That's about right here. And it's okay if this overlaps everything. That's not a problem. And I'm going to sketch a line. Now I'm going to come over here. So I did this one. And I'm going to do another one here, and that's going to be a 50-degree angle. So now my angle is going to open up the other direction. So I'm going to come over here and count 10, 20, 30, 40, 50. That is right here. And now I'm just going to kind of connect the dots, and you will see that you will cross through the other line. Here was my 80-degree angle. There was my 50-degree angle. You could erase all this extra, and by default, that will be your third one of 50 degrees because they all add up to 180. All right, question number 9. Asks you to classify the quadrilateral and find the missing angle measurements. So on your thinking map, remember we talked about sets of parallel lines, and you can see that this has one set of parallel lines, and anything that has one set of parallel lines is called a trapezoid. I'll switch to my pen so you can see better. So this is a trapezoid. And now we're dealing with quadrilaterals, so angle 1, angle 2, angle 3, and angle 4 will all add up to 360 degrees. Right here is my right angle notation, which is 90 degrees. So 90 degrees plus another 90 degrees plus 125 degrees plus this one that we don't know, we could label X. That's equal to 360 degrees. Now I can simplify. I add all of that up, I get 305 plus X is equal to 360. Now I just have a one-step equation, and I'm going to subtract 305 from both sides. So now I have X is equal to 360 minus 305, and that is 55. So your value of X is 55, which would make this 55 degrees. And this is a trapezoid. All right. Moving on to question 11, ask you to draw a rhombus with two 60-degree angles. So some important things to remember about a rhombus. All four side lengths are exactly the same. It's like a square that got caught in the wind. So we need to pick a measurement that would work for that. So I'm just going to go down here, and I'm going to say this line here is going to be 2 inches, and that's going to be my side length for everything. I'm going to go like this, and I'm going to draw my 60-degree angle, line it up, 60 degrees is right there, and I know that this line also has to be, oh look, this also has to be 2 inches, okay, and then this one's going to have to be 2 inches too, but we need to make sure that we line everything up the same. So I know if this is going to be 60 degrees here, you know that its opposite angle would be 60 degrees. And we know down here that a straight line would have to be 180 degrees. So if this one right here is 60 degrees, that means this one over here would have to be 120 degrees because 120 plus 60 is 180 degrees. So I'm going to go over here like this. This one's going to open up the same way. 120 is right here, so I'm going to make a little bit of a mark. And I know that this line also has to be 2 inches because that's what a rhombus is, all 4 equal side lengths. Sketch it out. Connect the dots. So there's my 60-degree angle, and there's my other 60-degree angle. And there is my rhombus. And we know that these are all 2 inches, so we can mark it. Alrighty. Number 13 asks us to find the missing dimension using the scale factor of 1 to 8. The first thing I'm going to note is that this one is inches and this one is feet. Always pay attention to your units. We have model over actual. Our scale factor here is 1 to 8. I don't know my model dimension, so I'm going to put my variable, and my actual dimension is 20. And it's given to me in feet. That means we're solving for feet here, and we'll have to convert to inches afterwards. So 8 times x is 8x. 1 times 20 is 20. Divide both sides by 8. X is equal to 20 divided by 8. You get 2.5. And that is feet. You're given feet, so we solved for feet. But we need inches. And I know that there are 12 inches in 1 foot. So if I take my 2.5 and I multiply by 12, that will give me 30 inches. Alrighty, number 15. Make sure you pause along the way and work through these problems. Number 15 says a scale drawing of a tulip, this should say, is 5 inches long. The actual tulip is 2.5 feet long. What is the scale of the drawing? So you can tell we are comparing inches and feet. So we have a certain amount of inches to a certain amount of feet. Well, what do we have? We have 5 inches is 2.5 feet. So right there is our scale. We could also write it this way, 5 inches, 2.5 feet. Doesn't matter. Remember, so that's scale where your units are different. Scale factor, the units are the same and they're not written on there. So what I can do is I can take my 5 inches and I can take my 2.5 feet and I can make these both inches to inches, and then we can start simplifying. So I know that this is 5 inches, and to change my 2.5 feet to inches, I would have to multiply by 12. So 2.5 times 12, that gets me 30 inches. So right now my scale looks like this, but I know 5 and 30 have a common factor of 5. So I can take this number and divide by 5, and this number and divide by 5, and I get 1 to 6. And there is my scale factor. Hope this helps.